This has been a really interesting conference, all these discussions about exponentials. And, I find myself reflecting on the contrast between the digital revolution that I'm emotionally familiar with, the one that's changed our lives in the last 20 years, and the digital revolution in manufacturing, which kind of is a little bit of a failure to launch. I mean, when you think about it, in the last 10 or 20 years, every aspect of our lives has been fundamentally changed by digital technology on a really personal level. Mobile phones, the internet, social media, taxis, hotels, literally everything. But on the manufacturing side, even though we've been dreaming about things since the 80s, for 30 years, we still haven't quite got there yet. And when you think about where is my local for local production, where's my on-demand manufacturing, where's the warehouse in the cloud, how come my factories aren't more flexible and programmable? It's sometimes it can be a little frustrating on the way there. And part of that are some of the reasons why the company that I work for, Carbon, those ideas were really at the heart of why the company was created. I'm just going to give you a little introduction, and then I'll move on to some interesting case studies. And what I'm going to do today is share with you some of my observations, both about what leading product companies who are using additive manufacturing are doing on the front lines, and also some trends and themes that I see emerging that I think are really important for product companies. We came out of stealth 2 years ago in 2015, simultaneously on the cover of Science magazine, and for you science geeks, that's kind of a big deal in science land, and also on the stages of TED, where our founder, Dr. Joseph DeSimone, unveiled what he and his co-founding team had created, which was a fundamental advance in the science of polymer-based 3D printing, which is probably why I was on the cover of Science. And for those of you who aren't familiar with our technology, essentially it's based on a digital light projector shining upwards through an oxygen-permeable optics layer, a little bit like a contact lens, shining upwards into a vat of UV-sensitive liquid programmable resin above. And unlike traditional stereolithographic 3D printing, which inherently creates layers, layer by layer, additive manufacturing, and those layers are introducing mechanical weaknesses, Carbon is able to precisely choreograph the relationship at the interface of light and oxygen to ensure that we can grow parts continuously, creating a truly monolithic, isotropic object. This is a fundamental advance, and what's really important is that we can do it incredibly quickly. And for those of you in manufacturing, you'll know that speed often means money. So net-net, and from a Carbon perspective, we can create objects that have no layers, so they have the same mechanical characteristics in all 3 dimensions. They have great surface finish and resolution, the kind that you would expect from final quality polymer parts, final quality plastic stuff that you're used to seeing all the time. It goes 25 to 100 times faster, which makes it economical for end use. And perhaps most importantly, because of the process we have, combined with a dual cure, post-cure thermoplastic step, we have access to a wide range, like the broadest range of materials in additive manufacturing, everything from a really squishy elastomer all the way to a high-temperature polymer that you could use under the hood or send through a high-temperature sterilizer. So all of this was based on our mission at Carbon to change the way the world designs, engineers, makes, and delivers final quality real parts. But speaking of production, I think all of us probably who spend our time here know that essentially the basic steps in the production process haven't really changed for a really long time. Basically, if you're going to make something, you make a design, and then you make a model, you make a maquette, you make a prototype, you get it the way you want it. Then you go over here, and then you tool it up. Typically, that's an expensive step, and you tool it up, and you go from there to final quality, to end-use parts. Now, I was talking about the digital revolution earlier. We've had a ton of innovation on the design step. Parametric design, generative design, 3D modeling, all of that stuff has really changed the way we design and conceptualize new products. But then when you're done with the design, you still go back to analog, into different systems, step by step by step, and then tool up. Now, there's been some really fundamental advancements in additive, and carbon is part of that new vanguard. There's other fundamental advancements in metal 3D printing as well. And what it means is that we're finally, at least in our little world on the polymer side for 3D printing, we're finally starting to get digital. And for those of you who lived through the digital revolution and remember what happens, like tower records and stuff like that, digital means you take away steps. Digital means you disintermediate the middle. In a production land, that means we're going to take out the prototyping step. We're going to take out the tooling step, and we're going to go to what we've been dreaming of for 30 years, which is to go directly from design, iterative, agile design, to end-use parts. And that truly is what we consider the future of manufacturing. Now, for a company that's kind of got its roots in rapid prototyping, our tagline today might seem like a little bit provocative. But when you think about it, when you're making stuff, if you're designing on a process and a tool with materials that are different from the process and tools and materials that you're going to use to scale up to final production at whatever your volumes, well, that's prototyping. But it's, in a sense, kind of a bit of a dead end. What we want to think about at Carbon and what we're encouraging our customers to do, and I'm going to share some stories about that today, is what happens when you design on the system and the process and the materials that are the same system, process, and materials that you're going to use to scale to end-use production. That's where we need to be. About a year ago, we started working with Adidas. And this is a tremendously design-driven company that really understands its visions around cities and local-for-local production and speed, and really understands the idea of open source and working with creators. And they were looking for a partner that could help them bring alive their vision of additive manufacturing capabilities coming to performance athletic footwear. Together, we created what is really a seminal, advance in additive manufacturing, the first real high-production, at-scale performance footwear in the athletic sphere based on 3D printing. But don't take my word for it. I've got some folks from Adidas. They couldn't join today, but they'll be able to talk in this film.
When we first started with the idea of Futurecraft, it was to sort of guide us, to set us on a path.
It's a mindset and it's a philosophy to try things.
We're always bringing in new influences, new ideas, new collaborations. 3D printing, for example, was one of these new technologies that really had unlimited possibilities. The initial problem was, okay, can we actually make a running shoe out of 3D printed material that really works and works well?
So when we started thinking about doing 3D printing, we wanted to use liquids, because liquids give you the most flexibility in material design. I think of light as a chisel. Light triggers the solidification of the liquid, but oxygen inhibits it. That allows us to have the object grow.
What's really interesting about this collaboration with Carbon is we're seeing a convergence of a completely new manufacturing technology.
We're going to scale it with the best industrial partner in the business.
We're able to deliver tens of thousands and moving to hundreds of thousands and into the tens of millions. That's clear in front of us.
We have this amazing opportunity to innovate the printing process, the liquid rising.
And growing in that context can give you new design thoughts you've never had before and new performance capabilities that wouldn't be possible by traditional manufacturing.
This three-dimensional mesh structure, it's a lattice, it's a matrix, it's a web of individual elements. Each one of those little elements is tuned specifically for a purpose.
These lattice structures behave quite differently than anything we've dealt with before. They're much different than foams. Now we have every individual area of the shoe to work with, which is a completely new horizon for us and a new venture.
If you really want to make a shoe that's a size 9, that same shoe for someone who's 180 pounds versus 100 pounds has got to be different.
We can go in within every single cell and engineer that exact cell to do exactly what the consumer needs it to do just for them.
That's fascinating. That's going to change how we create products and certainly how consumers experience products. And I think that's how we see something like Futurecraft 4D playing into the life of an athlete. I would say this is just the very beginning, and that sounds silly and cliche, but who knows, man? I don't know what's next, and that's what's great about going to work every day.
So if there was any doubt in anyone's mind that polymer-based 3D printing is ready for at-volume manufacturing, I think this partnership with Adidas and the announcements and the plans that we've made together are answering that question. This was really a different way to create a product and really represents, I think, breakthrough design and performance. I mean, typically, the amount of material iterations that you're able to go through are quite limited. When we were working with Adidas to create this product, we went through 150 material iterations in the space of months. We went through 50 different lattice designs that were driven by the athlete data and driven by aesthetics and different types of designs that we were able to do. And every one of those designs wasn't a prototype. It was an iteration of a final part, which is a really different mindset and a different way of thinking. You know, we've announced that we're going to be making 100,000 pairs of these shoes next year, and the first drop of 5,000 will be available in this fourth quarter of this year. That's a really big deal. That's not a science project. That's real final part production. And I think perhaps most exciting is the announcement and the celebration of Adidas's ambition to take this to real, true mass customization and co-creating with consumers. I think it's really interesting to reflect on that partnership with Adidas and the kind of company they are. And one of the things that, for me, really starts to bubble to the surface is when I think about the companies that Carbon is working with, and we're working with many companies we can talk about, companies, you know, such as Oracle and BMW and Adidas and Johnson & Johnson and Delphi and many, many other leading companies that we can't. Surprisingly, working with Carbon is sometimes considered a bit of a secret competitive advantage. But I wanted to share with you some of the emergent themes. I'm a strategist, so I'm looking for patterns. And I'd like to share with you kind of a few observations that I've gathered, seeing how companies are thinking differently and what aspects of the advantages of additive manufacturing do I think are going to affect the competitive capabilities of companies and their ability to innovate in the future. When you kind of like cut through a lot of the mumbo-jumbo, what you see is that one of the critical factors of this technology is that it really places the designer at the center. And this is the designer of the experience, the designer of the product, the designer of the business model, and finally the designer of the business program right at the center. And it makes it possible for them to manifest their vision directly into the world without a lot of these constraints. And I think this is a critical theme, and we're starting to see design-led companies winning. I think the idea of static versus dynamic is something to think about. When you think about it, products used to be a physical static output of a process. But with additive technologies, things are a little different. The physical characteristics of products can change over time. And when I was thinking about what Pablos was talking about, we're going to be able to A/B test physical products pretty soon. That won't be difficult. That'll be possible with the push of a button. And that's really going to change the way we think about the kinds of products that we create. When we think about what additives can really bring, what I see is that leading companies are designing for the process, and they're figuring out how to design for the process. They're looking, hey, where can I make products that have, where can I take a multi-part assembly and turn it into one thing? What kind of opportunities are there in my business for mass customization? Where can I look for high mix, low volume things that ordinarily I wouldn't tool and do, and I can create those businesses? So they're thinking about that and training their organizations how to do that. And doing a pilot and creating an end-use part is probably the best way to get there and the best way for your organization to learn. I'm going to say a quick note about provenance. This is a term from the art world that means like the history behind the piece. But increasingly, parts created with additive technology are going to carry all their born-on data with them. And this is particularly important for regulated industries. You're going to be able to know when it was made, what was the resin batch, who was the operator, how long did it sit in the loading dock. And all of that information is going to be able to inform you when you, for instance, have a product failure. You'll be able to find the products that had the issue or analyze the reasons as opposed to just guessing and recalling everything. This is going to really change how we think about risk, and it's really going to change about how we think about data when it comes to physical goods. So in closing, what I'd like to say is when I think about what leading companies that we're working with are doing, and how they're thinking and changing their organizations to take advantage of the possibilities of additive manufacturing, what I see is that they are starting small with a real part or a real product, and they're challenging themselves to get that out there. This is the image from Oracle. Oracle recently, working with one of our contract manufacturers, created a small run of 10,000 end-use brackets to go in their server farms. That was challenging the organization to figure out how do they design a final end-use part with additive that they're really going to use. There's another mark here from BMW with their Drive Now program. For the last year and a half, they've been working with us using customized exterior side scuttles on the BMW Minis, driving around Munich and in Germany. And so this is how we really need, and along the way, companies like that are starting to learn. You know, with Adidas, like I said, we're making 5,000 this year, 10,000 next year, and the sky's the limit. And what they started with was they didn't roll out additive across their physical plants. They started with a single proposition, challenged themselves to an end-use part or end-use product, and in that way, their planners, their strategists, their engineers, and their designers are starting to learn about additive. So it's been really exciting to see how our companies have been taking advantage of these great capabilities, and I'm looking forward to working with more of you and more companies like the ones we're working with now at Carbon.
Awesome. Thank you, Valerie. That was awesome. Did I promise too much?
Thanks.
Thank you. It's really exciting to be here because last year we were here and I talked about 3D printing on the main stage, and this year one of the participants came back to me and said, actually, we started using additive in production. So the iteration cycle is really fast. If you want to talk to any other participants on the stage today, they're going to be around a little bit, so please do that. But meanwhile, maybe some of you have questions that are directed towards the use of additive or maybe driving agility in your organization through production.
Anesthesiologist from Texas. So my patient usually need some lumbar support or cervical support or neck color. Is there any, well, I'm sure there is, it's just how to get to 3D printer to make a customized support instantaneously as a patient needed?
Yeah, I mean, there's a lot of promise there. So from a process standpoint, that's absolutely something we're working on, those types of bedside and even surgical side or chairside applications where we're working with companies to help them create customized possibilities. I think, we're a startup at Carbon, and depending on whether it's on the body or in the body, I think there's oftentimes much longer lead times from a regulatory standpoint, in terms of getting a lot of that stuff cleared through the FDA, so it depends on those types of things. But we're already working on things like surgical guides, we're already working on dental applications that are quite close to market, and then there's much more long-term things that are being worked on in terms of what's internal. But for now, I think for a lot of the early stage companies, the regulatory hurdles to get a specific product approved, I think will mean I think we're at least 5 years out from seeing some of that stuff come to market. The issue isn't the process, the issue is the regulatory hurdles.
So I have a few things that I found help a company that does sleep apnea masks, and they're going to, there's a couple of them actually in the 3D printing space now. One of them is MetaMason that is doing this scanning to production part, and that's really interesting because it's of two things. First of all, it's showing the path. It's relatively easy to get these things approved. It takes 6 months, right? Because they're not in the body. They're just kind of outside. And the second part is that they're automating the scan to design value chain to a degree that we've never seen before. So that's something you can rest on. So in the future, you can just go along, scan, and then you can actually get a 3D printed part, whereby before it was a little more difficult. You'd have to have a technician design the part, etc. So that trajectory is, or that value chain is being shortened a little bit, and allows you to then take advantage of it for side kind of applications that maybe haven't got such a big market appeal. Yeah. The big thing to remember is that in additive, and Carbon tells this story better than anyone, that application developers are the ones who have the power. We know nothing. right? The guys that develop software or that develop the equipment have no idea of how this technology needs to be used. So when it comes to regulatory hurdles, for example, or applications around the body, you guys know better than anybody, and the OEMs are just waiting to hear from you, just waiting. They can't. Everybody's going to be jumping outside the body, just trying to talk with you about developing some of these applications with you.
Yeah.
So come with your problems, and if Carbon can't help you, one of the other manufacturers is going to want to help you.
Yeah, we can give it a shot. There's been tremendous advances in biocompatibility in the additive space, and I think, for instance, we've recently cleared biocompatibility ratings for all of our all the materials that we offer. So I think that's one of the big factors that you're starting to see increasing material maturity in additive companies.
Yeah, great. So more questions later on. Thank you very much, Valerie. Appreciate it.
Thanks.